Welcome to this presentation on GCSE Chemistry, with a focus on AQA exam-style questions. We will explore the questions focused on the topic about chemical reactions and energy changes, specifically acids, alkalis, and neutralization from the 2023 Higher Tier Chemistry paper. I'll guide you through the answers step by step and explain how they align with the marking scheme. Question 5. This question is about acids and alkalis. Subquestion 5.1. Ethanoic acid is a weak acid. What is meant by weak acid? Answer in terms of ionization. 1 mark. Thus, the question here refers to the definition of a weak acid in terms of ionization. Let's recall some everyday examples of strong or weak acids. We can easily see where these acids are found, their strength, and what is their uses. We have hydrochloric acid and sulfuric acid, for example, as strong acids, then citric acid and carbonic acid as weak acids. We can look at one strong acid, such as hydrochloric acid, and one weak acid, such as vinegar or ethanoic acid, and write their dissociation reaction. In other words, to see their ability to dissociate in water. Hydrogen-chlorine bond is weak, so it fully dissociates, and the arrow indicates that this is irreversible because chlorine ion is very stable. It is called a strong conjugate base because it can remain in solution without rejoining the hydrogen ions. We can see how each ion of chlorine and hydrogen dissociate fully in water. If we now look at vinegar or acetic acid, which is a weak acid, we can see that it dissociates into acetate ion and a hydrogen ion. The oxygen-hydrogen bond in the carboxyl group is stronger, so it partially dissociates. The conjugate base acetate ion is less stable and can reabsorb hydrogen ions, making the dissociation reversible. Thus, weak acids like vinegar or acetic acid only partially ionize, where some molecules of vinegar remain undissociated, whilst others dissociate in hydrogen ions and acetate ions, as we can see in the beaker. Therefore, the answer to our question is, a weak acid is one that partially ionizes in solution, meaning only a small proportion of its molecules release hydrogen ions. This response fully aligns with the marking scheme. Subquestion 5.2. The concentration of an acid can be measured in moles per decimeter cube. Which combination of changes increases the concentration of an acid? Tick one box. Concentration tells us how much acid is dissolved in a certain volume of solution. It's calculated using a simple formula. Concentration equals mass of solute divided by volume of solution. Remember of an everyday life example. Think of how you made orange juice from concentrate. Adding more concentrate makes the juice stronger. Using less concentrate, but same amount of water, makes it more diluted. Doubling both keeps the taste the same, like keeping concentration unchanged. So it will be the same with any other solution or acid. So what combination of changes increases the concentration the most in our question? The answer is simple: doubling the mass while halving the volume. This makes the acid solution much stronger. The answer fully aligns with the marking scheme. The concentration of an acid can be determined by titration. An indicator is added to an alkali in a flask. Name an indicator that can be used in this titration. Give the color change of the indicator when acid from a burette is added to the alkali in the flask. 2 marks. You will need to answer the name of indicator and color change. If we recall, the pH scale measures how acidic or alkaline a substance is, ranging from 0 to 14, acids with pH between 0 and 6, neutral substances with a pH 7, and an ordinary example is water. And lastly, alkalis with pH between 8.0 and 14.0. Now, what is titration? Titration is a practical technique used to determine the exact volume of acid needed to neutralize an alkali, or vice versa. In titrations between a strong acid such as hydrochloric acid, And a strong alkali like sodium hydroxide, methyl orange, or phenolphthalein are commonly used as indicators. Phenolphthalein is the best indicator for acid-base titrations because it changes from pink in alkali to colorless once the acid is added to neutralize it. The answer is therefore simple, stating phenolphthalein as indicator that changes its color from pink to colorless by adding acid to alkali. And this aligns with the marking scheme, which awards 1 mark for naming phenolphthalein and 1 mark for correctly describing its color change. Sub-question 5.4. Sodium carbonate dissolves in water to produce an alkaline solution. Give the formula of the ion that makes the solution alkaline. 1 marks. This question refers to understanding how substances like sodium carbonate influence pH. Now, sodium carbonate, also known as baking soda, is a water-soluble basic salt that firstly dissociates into sodium ions and carbonate ions when dissolved in water. This is an irreversible reaction. The carbonate ion undergoes a reaction with water, known as hydrolysis, which leads to the formation of the hydroxide ion, making the solution alkaline. Therefore, the correct answer to the question is the hydroxide ion, for which you will earn full marks according to the marking scheme. Sub-question 5.5. A student does a titration using sodium carbonate solution and nitric acid. The equation for the reaction is sodium carbonate reacts with nitric acid and forms sodium nitrate, carbon dioxide, and water. 25 cubic centimeters of 0.124 moles per decimeter, cube sodium carbonate solution is neutralized by 23.6 cubic centimeters of nitric acid. Calculate the concentration of the nitric acid. Give your answer to 3 significant figures. You should calculate the number of moles of sodium carbonate in 25.0 cubic centimeters of the solution, the number of moles of nitric acid in 23.6 cubic centimeters of the nitric acid. The concentration of the nitric acid in moles per decimeter cubed 5 marks. To answer this question, we will need to recall the formula for moles calculation, which is given by the formula moles equals concentration times volume, where concentration is measured in moles per decimeter cubes and volume in decimeter cubes only. This tells us how much of a substance is present in a given amount of liquid. For example, we have 200 centimeters cubes of potassium chromate solution in each beaker, but only 30 grams of sugar in the first beaker and 50 grams of sugar in the second beaker. This tells us that there is different amount of substance in this case of sugar in 220 grams of potassium chromate. The subunits of centimeter cube is decimeter cube. So we are going to convert the values in decimeter cubes to be able to calculate the volume and concentration of a given substance. Another concept which we'll need to apply in this question is about the moles ratio. And this is very simple. If we have the general formula of a chemical reaction where the reactants are represented by the capital letters A and B, whereas the products are represented by the capital letters C and D, then moles ratio is given by the coefficients in the lowercase letters A, B, C, and D. The mole ratio in the reaction will be of A to B to C to D. For example, in the reaction of hydrogen with oxygen, we will have to react 2 moles of hydrogen with 1 mole of oxygen to obtain 2 moles of water. So the ration is 2 to 1 to 2. We can use the mole ratio concept in our problem. The chemical reaction given is already balanced, so we can identify the moles of each substance. We have 1 mole of sodium carbonate, 2 moles of nitric acid, 2 moles of sodium nitrate, 1 mole of carbon dioxide, and 1 mole of water. We can also annotate the volume of 25 centimeters cubes with V, the concentration of sodium carbonate with C, and the volume of nitric acid with C. Now, the volume of sodium carbonate is given in centimeters cubes, so it needs to be converted into decimeters cubes. We have 25 centimeters cubes equal to 0.0250 decimeters cubes, since 1 centimeter cube equals to 0.001 decimeters cubes, as we recalled earlier. Next, we will use the formula to calculate moles, which is concentration times volume, to find the moles of sodium carbonate. Simply, we multiply the concentration of 0.124 times volume of 0.025, which equals to 0.00310 moles. These are the moles used in the student's titration, not in the standard chemical reaction written above. But we can use the moles ratio from this chemical reaction. From this, we see that 1 mole of sodium carbonate reacts with 2 moles of nitric acid. So, the moles of nitric acid required will be 2 times 0.00310 equals 0.0062 moles. We can use this to do the last step calculation of concentration of nitric acid by using the moles formula from above. Concentration equals volume in cubic decimeters divided by moles. We notice again that the volume of nitric acid is given in centimeters cubes, so we convert this into decimeters cubes, and we obtain a value of 0.0236 decimeters cubes of nitric acid. The concentration of nitric acid will be the moles of nitric acid, which is 0.0620, divided by the volume of nitric acid, which is 0.0236. So the answer is 0.263 moles per decimeter, cubed. All the calculation steps done are also found in the marking scheme, which leads to the final answer of nitric acid concentration of 0.263 moles per decimeter cubed. All these steps of working out from are required, so you show the examiner how you found your final answer. When hydrochloric acid dissolves in water, hydrogen ions and chloride ions are produced. Subquestion 5.6, a solution of hydrochloric acid with pH 4.5 has a concentration of hydrogen ions of 3.16 times 10 to the power of -5 moles per decimeter cubed. What is the concentration of hydrogen ions in a solution of hydrochloric acid with pH 2.5? 1 mark. This question refers to the pH of a solution. So firstly, what is pH again? pH tells us how acidic or alkaline a solution is. And secondly, how does pH relate to hydrogen ions? The more hydrogen ions H+ in a solution, the lower the pH. The formula for pH is pH equals -log of hydrogen ions. This means that pH is based on the concentration of hydrogen ions. To find the hydrogen ion concentration from a given pH, we rearrange the equation. Hydrogen ions concentration equals 10 to the minus pH. Now let's apply this formula to our question. To calculate the concentration of hydrogen ions for a solution with pH 2.5, we use the formula mentioned earlier. pH equals -log of hydrogen ion concentration. Rearranging for hydrogen ion concentration equals 10 to the negative pH. In our problem, pH equals 2.5. Substituting this into the formula, hydrogen ion concentration equals 10 to the power of -2.5 equals 10 to the power of -2 times 10 to the power of -0.5 equals 0.01 times 0.316 equals 0.00316 equals 3.16 times 10 to the power of -3 moles per cubic decimeter. And this is the correct answer, which fully aligns with the marking scheme. Subquestion 5.7. Which element has atoms that have the same electronic structure as the chloride ion? Use the periodic table. 1 mark. To answer this question, we will need to recall the theory referring to electron configuration for different elements from the periodic table. Looking at chlorine in periodic table, we can see that it has an atomic mass of 17. This means it has 17 electrons and 17 protons. The electrons are arranged in shells, so we'll have 2 electrons in the first shell, 8 in the next shell, and 7 in the last shell. So its electronic configuration is 2, 8, 7. Atoms want a full outer shell to become stable, like the noble gases in group 0 in the periodic table. Chlorine has 7 outer electrons, meaning it needs 1 more electron to complete its outer shell of 8 electrons. Chlorine gains 1 electron to form a chloride ion and has now a total of 18 electrons, just like argon from the periodic table. So, the answer to our question is argon, as it has the same electronic structure as the chloride ion. This fully aligns with the marking scheme. And that's a wrap on today's exam-style question. Keep at it, stay positive, and you'll have these down in no time. Got a tricky one you're stuck on? Pop it in the comments and I'll help you out. Don't forget to like, subscribe, and tap the bell so you're always in the loop. Catch you next time.